the recording. So this is the L1 device. It's already started. Since you don't have the device set it up, I will show you the same photo that is already in the manual. This is the, oh, sorry. So let me share the screen. Can you see? Okay, now. So this is the back of your device. You can see 3 and 4 are fuses that you will not need to touch anything for now. What you will actually need is to connect the power supply cable in position 1 here, and the USB cable in position 2, and turn on the device. After you do that, you have to go in the front of your device. The device will be on. There is a possibility if they hit, there is a switch for to turn on and off the heater. Here is on the position on, and also you can see when it's on, you will see the light blinking, and it's mostly light when it's the temperature is going up. The device is ready for use, and also the sensor. You receive a stand with the device and the wrench. So I will turn it on. I have already water inside my bucket. Sorry. Can you see the video on screen?
Yeah, it looks good now.
Okay. So here, as you can see, if I even bring it closer, you can see the sensor with the wire between the clamps. In the sensor there is already a platinum wire. In case for any reason the wire breaks, or you take some measurements and it gets dirty or bent it or anything, it's very easy to replace it. We supply you with an Allen key, so simply you unscrew the screws on the 2 positions, and then you set the wire in one position, you screw, and then you tighten it. The wire should be tight, but not over tight, not so much in tension, because if it's in tension, then it can break at higher temperatures. So you can leave it a bit slightly loosen, and tight the screws, also top and bottom. And yeah, it's very easy. In few minutes, if you try it once, maybe it will take a couple of minutes, but the second time it will be much easier. Also, there is an O-ring. We supply you with 2 different types of O-rings. In case one breaks, also you can check the compatibility of your fluids that you are measuring with the O-rings. And also you have the bucket, and when you fill the bucket, you can leave a couple of millimeters from the top of, so the fluid will not overflow. But even if it's overflow, when you tie it, you will see that the fluid is coming on the top. If you want to ask anything in between, I don't mind. So also, with there is this hose that is it's a port in order to connect the external pressure, so apply back pressure to your fluid. It's really easy to set it. You just screw it here and you connect the hose that is coming from your pressure cylinder. You can supply argon or nitrogen if you want. And yeah, also, unfortunately, I forgot to bring this part. We supply you with an overpressure sheet. So if you want to have a closed cell, but you don't want to apply any external pressure, you can close your cell. And in case that we think the increase of the temperature, the pressure inside your cell increases above 20 bar or 25 bar, then automatically it will open and vent the pressure so it will not damage your cell and your device. So as I said to Jake in the beginning, there is a heater inside the device. You can go at, depending on the temperature in your lab, you can start measuring measurements from 10 degrees to 200 degrees, but also depending on the temperature in your lab, you can start measurements from 5 degrees or 0 degrees, but in that case, you will need to wait extra time. If you actually turn the heater off and leave it few hours overnight, you can easily next morning reach temperatures around 0 degrees. But still, if the temperature in your lab is 35 degrees, maybe it will be hard to reach these temperatures or the 0 degrees, or will not be very stable. But 5-10 degrees, it's standard temperatures you can reach. Do you want to ask anything else here? Something that I feel that it's really straightforward and I forgot it.
I have a question
Yeah.
for that valve that goes over the pressure, that
Yeah.
extra part. Did you say that that is like a pressure relief valve? Like
Yes.
if it pressurizes, it'll pop.
Yes. It will pop. Yes.
Okay.
It's just in case that you want to have a closed cell, you don't want to apply external pressure. And it's for depending the fluid you are measuring and the temperature range you have. If the pressure increase above 20 bar 25, then it will pop and it will release the pressure.
Okay, thanks.
That covers this as well. If you have any other questions about that, and you can email us as well if you still have unanswered questions after consulting the manual.
Another question that I have is
Yep.
for the USB, we would have to go through a process for me to plug that in. Would you be able to send me the I'm guessing it has like the software and like maybe the manual on it. Would you be able to send me that through email instead?
The software and the manual.
Just the contents of the USB that came with the
Yeah, we can do that.
Okay. Yeah.
shipment. Yeah, that'd be awesome. Thank you.
Yeah. Anything else about the sensor and the device for now? If not, I can move to the software. Okay, I think if you don't have anything else to ask, then I will share my screen and show you the THW software. So I suppose that in the USB there is a link, an application for the THW software. And when you install this software version, you will and open it. You the first screen. This will be your first screen. When you open it directly, it will detect the device, the THW, and the port where the device is connected on your computer, and also it will detect the water low back, the heater of your device, and the port where is it connected. Also, you can add the user ID name, so you can keep with the user that is connected. In that case, it takes the name of the user of the computer. You can add the sample name. In my case, okay, I will put it first aside. In my case, for example, I have DIUF water. And you have two options. One option is you can manually add the power that will be applied to your fluid in order to take the measurements. And the other option is to detect automatically the power. So if I press the detect power option, actually what it does, it takes a measurement and it calculates a thermal conductivity, and according to this thermal conductivity, it follows an algorithm and calculates the preferred power that should be applied to your fluid in order to take the thermal conductivity measurements. So in that case, I have water. It detects the power, which is it, 291 milliwatts. And also below that, you can see that you have the test time. The proposed test time is 1 second for fluids. In case you are measuring other fluids, or you can advise us. Usually you will not need it. There are also different times, but the default value is the 1 second. Also, there is an option to add densities for your fluid, you are measuring. You don't have to add these densities. You can leave it blank. For example, here, because earlier I used a density file, it has the default values. Also, you can change the temperatures and the density. You can save it, give a name, and save it in any folder you want. Also, if you already have saved this density file, you can just press load densities. I have a water density file that I saved it earlier. So you can see here that already is using the water density file. After that, you save. Sorry, I was taking some measurements earlier. You see that if you had measurements from before, it reminds you again if you want to save the previous data before it erases them. I didn't need the data. If you save them, they still remain saved in the folder. If you don't need it, just clears the screen. And now you're in the area where you can see your measurements. So ideally, after the detecting power, you have to wait 5 minutes. We waited a few minutes because I was explaining you the details. So you have the option to run a single test. when you press it, it asks you if you really want to run a test. You press OK if you want to continue. So what it is doing is taking a 1 second measurement and then calculates the thermal conductivity, the thermal diffusivity, the volumetric specific heat for this fluid. And in case like ours that we already upload the density file for the water, it calculates the heat capacity for the water. Also here, if you see, it shows you the quality of the measurement. And the quality is good. It means that the measurements are good. If you go in the graphs below the measurements, after you clicking on the measurement file, you can see that you have a graph that is actually the temperature rise as a function of the logarithm of time. And if you right click on this graph, you can select between different types of graphs. So you can select the same figure of the temperature rise as a function of temperature. And here it shows you also the time range in which we calculate the thermal conductivity. And the other one is the scatter graph, that it shows you actually if the measurements are good or not. So the criterion to have a good measurement is like the most of the measuring points to be between 0.05. If the most of the fluids, if the most of the or more of the measuring points are above 0.05, then you have a quality that is okay. And that case also can be a reason because you have very high or very low power applied to your measurement. And in case you have a curve or many points in a very high deviations, then you can see also poor quality. In this case, depending what you are measuring, it can be in a case like that, like water, maybe it means that you shake your bucket, so you just put it inside and you measure. Maybe it's a sign that the you don't have enough fluid inside. If you leave it overnight, took measurements, high temperature, and you leave it and you measure again at 20 degrees. Also, it can be a sign that you have a very low or very high temperature rise. So how you can see if a measurement is good? First of all, for a good, one thing is the quality. You can see if it's good, it means the measurement is good. Another one is the temperature rise that you can see here. It should be between 2 and 4 degrees. Sometimes can be lower, slightly lower than 2 or slightly higher than 4, but it should not be, for example, if it's 5 or 1, then the measurements will not be good. Yeah, if you see, for example, for a fluid that you measure it again, that the power you get is totally different, then there is a problem with the fluid. Usually, if you see a bad quality of a measurement, the first thing you have to check is the temperature rise. For example, for an empty bucket, you will see a temperature rise that is really high, maybe 8-10 degrees. So it means that actually you heat air. Or in some cases, you can have a very low power for any reason, and then you will see temperature rise that is 1, and then actually you don't give enough power to heat the fluid. Any questions here? Because I think I said lots. Do you want to ask something?
So I noticed that the power is now 330.
Yeah, the power is now 330 because I was making some changes before the webinar, and I was trying to find the software version the same like the one you had, but we are in between doing some changes, and I didn't change some settings so to get the same power. Like usually you will have, because you take a measurement again, you will have a power difference around 10 to 15 milliwatts between the detecting and the applied power. But in that case, because I half an hour before the webinar, I update the firmware version and I didn't change the settings in my device. That's why the applied power here is higher. I know that. If you notice something like that, you have to come back to us, contact us, and let us know that the power we get is really high or really lower than the detected one, so we can fix it. But the final result, I don't worry in that case, because the final result, the temperature rise is below 4 degrees, and I know that it's a good measurement. If I get something different, that usually the water gives me from 270 to 350, depending the sensor and the conditions. So it's not something to worry. Otherwise, I will change it. So yeah, but if you notice anything when you start your measurements, please contact us because you help us to help you.
Okay. Okay. Yeah, that makes sense.
Yeah. So as you can see now, the thermal conductivity, because as I told you, I just update the firmware on the device. So the settings were not all updated. You can see that the thermal conductivity value is not correct for 20 degrees. So in that case, and in any case, you take measurements and you doubt and you want to confirm for the right operation of your sensor. After you can take 1 or 3 measurements, depending. You can do it with 1 measurement. Usually, I calibrate my sensor with 1 measurement. You go in these 3 dots on the right up side, and then you press calibrate conductivity, and you set the value you want for the thermal conductivity of your device, and you press OK. And then it starts calibrating the instrument. And you will see after it finishes that you will get the right thermal conductivity value. So from here, usually we suggest to start a new test, but if you want to keep it as a record that you really, or you can save it, but if you want to keep it or continue with your measurements, you can continue with your measurements, either taking one more single test or going to the schedule side. And from here, if you press add, you see that you have different options. I will start first with the single options, and then I will go to the temperature steps. So you have the option to put some waiting time before you start the measurements or in between the other steps. You can press to go to temperature. So in that case, for example, if you go to 20 degrees, or 30 in our case. You want to change something. You see that we can set the temperature 30 degrees. There is a higher limit. You should be careful when you set the steps manually to change this higher upper limit of your device in the very high temperature. We can put it to 10 or to 200 degrees. Otherwise, it will stop working, and you will need to set the limit temperature on your watt low again. So you saw that earlier because when I went to go to temperature, it was 20 degrees. The upper temperature went to 30 degrees, so I had to change it to 10. So what it does, this step actually it sets your watt load to 30 degrees and has a waiting time until the temperature will stabilize. Usually it's around 25 to 35 minutes. And from there, it starts taking measurements if you continue with measurements. So from here, you can add a waiting time if you want. Also, usually we advise to select the detect power at each temperature step. And actually what it's doing, it's every time before starting the measurement at its temperature, it detects again the power for more correct measurements. You can add another waiting time. You can change this waiting time for 5 minutes. Usually 5 minutes is enough. And then you can run tests. You can say, okay, I want 3 measurements or 5 measurements every 10 or 5 minutes. Usually I change this time. And then after it follows these steps, it's taking the measurement, and before it can stop there if you don't set another option. Also, you have the option to set a specific temperature. The difference here is that it sets directly the watt low at the temperature that you are setting. And if, for example, now you say, okay, I set the temperature, let's say 50 degrees, that's higher than the first, that is 30. And then select run measurements. Then directly, when it sets the watt load to 50 degrees, it will start the measurements. It will not wait for the temperature to stabilize at 50 degrees. So it's moving directly to the next step. Also, if you do this, the manual schedule, you have the option to delete some choices, or you can put some steps higher or lower, depending what you prefer. And also, if you have a very specific schedule, you have the option to save it somewhere in your folder. And of course, after you save it, you have the option to go in this folder, upload this schedule again. Or if you don't like anything, or in my case, because I want to show you something else, you can just delete all the manual schedule. Also, you have the option. What? Yeah, you have the option to select the temperature steps, and in that case, it gives you a start temperature and ending temperature. The temperature steps you want to follow, and a higher temperature limit. Actually, it's all in one. The manual steps you edit earlier. In our case, let's say we want to start measurements from 10 degrees and go to 90 degrees. Every 5 degree step, you see here there is a higher limit. If I don't like to keep it 100, I set it 110. I can change the number of tests. Usually I put a 5 minutes delay measurement time. And here you can keep the auto detecting power at its measuring step, or you can say, okay, I don't want to detect the power at its time. My advice is it's 5 minutes delay to your measurements, and in order to make your measurements better, so it's better to keep the detect power for all your measurements. Also, you have the power here in the testing time. If you press OK, you can see here all your schedule, in which if you want to make, for example, for some reason, you want to see the properties or you're not sure that something is stable, you can change the temperature in the schedule. You can go directly here and change it. You can change the delay time, or you can add a number of tests or increase or decrease the delay time. Also, you can go even here and add any other option and put it in between your schedule. If you press start, just to make sure that you will always have your results saved, it asks you to save your test in your folder that you want, and you see that you the green step shows you where you are in your schedule. You have the option to stop your schedule, or if you think that, okay, the temperature is quite enough, or I change my mind, you can force to the next step and continue to the next step. Any questions now? Hello? I think we lost Carla. Jake, can you hear me?
Yeah, I can hear you. Yeah, I don't have any questions. It all seems pretty straightforward.
Yeah. Right now, let me check if I have another. Okay. Or if you go to the TC VST graph, you will see the thermal conductivity change with the temperature. But now we're going to stop the schedule because I cannot do anything at this point. And I can go in, no, I don't want that. I can go in my folder and show you some previous measurements. So in that case, you can see I have ethylene glycol results with different temperatures. And in this case, you can see after you finish the schedule, you can see the temperature, the thermal conductivity as a function of temperature, all your measurements. This is the previous schedule, we don't want it. But also from here, you can see also if the quality of your measurements are good. Here you can see the temperature rise was higher than 4 degrees, but since the quality of the measurements were good, it was fine. Also, we saw that the other graphs look okay and they were not noisy, so we could continue with our measurements. Also, after you finish your measurements, case, okay, I will show you the results I already have. As I said, I press open the file to open a previous measurement. I can also save the same file in case I'm not sure if I want to save it in a different folder. I have the option to generate a report that actually it opens an HTML page and you can save it anywhere in your computer. Here you can see also it shows you the software and firmware version you're using, that in case you face any issues, it will be easy for us instead of looking to let us know, we have this firmware software version. And also you can export your results to an Excel with any name you want and save it in your folder. And actually, if I go to my, give me a second to open my folder and show you after it will save how the file will be. It takes some time, depending how many measurements you have. The procedure is faster or slower.
So while we wait, I just wanted to let you know Carla had audio problems, so she's gonna watch the recording later. But
Okay, I'm sorry about that.
yeah, no problem.
So it takes some time to save the file, I will stop sharing this screen and I will share another screen with another measurement file. These are water measurements. So here you can see that actually you can see the sample name, temperature, thermoconductivity, all the properties you can see. This is a previous version when we didn't have the density and the heat capacity, that they will be added in the latest version. So you have all the measure and calculate properties, also the heating power, the temperature rise and when you got the measurement. And next to these results, you will have the graph of the thermoconductivity as a function of temperature. And next to this summary, you have also the temperature rise as a function of time graph for each one of your measurements. Now, if you want to see how are your results and what's the problem if you notice any problem with your measurements. So let me, yeah, this file I opened it was quite large, so it's still exporting the data. So I will share my screen again, and you see after it's exporting the data to an Excel file, you can go again to your new to the screen as before. Something else I forgot to tell you. If you go to the three buttons here to the three dots and you go to the settings. Okay, you will not see the one screen. You will see this screen when you have the, you will see only this screen. You will have to choose between the advanced mode or not. In the advanced mode, you will be able to see all the properties as they are here. But if you choose to disable the advanced mode, you will only see, actually you will not see mainly the power and the temperature rise for its measuring step. Other than that, the temperature and the thermal conductivity and all the properties that you measure or calculate will be there, plus the quality of the measurement and the time that we took the measurement. Also, you have the option if to enable a temperature tune file. In case you take some measurement and you see that there is any delay. So it remembers and goes faster to this temperature, but usually the measurements are really fast, are 25 to 35 degrees at higher temperature, the measuring of the time between each temperature step. And also you have the option to email, to send an email to yourself or a colleague when the measurements are completed. And also you can send an email with your with the results to your email address. After you put all the details, you just save it and it's all done and ready. Also, you have the option, I think, I'm not 100% sure because the sensor came with the temperature calibration already. Maybe you have this calibration of the PT100 sensor. If yes, then you press this button if you doubt about the temperature and you set the new temperature of your fluid. But I don't want to lie, I'm not 100% sure if this is the experimental option we have that we want to implement in the future. Jeff, do you think I forgot anything? Or if you
That's
want,
pretty much it.
yeah. Do you want to ask something else, Jake?
So for calibrating conductivity,
Yep.
that is with
Water.
the water that we received in
Yes.
shipment. Okay.
Yeah. You received, and also in the manual, you will see that says you can calibrate at 20 degrees, 0.598 watts per meter Kelvin. If for any reason the most of your fluids are higher viscosity, or you want to be sure that in other thermal conductivity or viscosity range, you want to make sure that you have a different calibration, you can use you can use ethylene glycol also for the calibration of your device, of your sensor. But from us, we propose that since the water is a reference fluid for the thermal conductivity, we propose calibrate the sensor with water.
Okay. And do you recommend just calibrating once or periodically?
It depends from the use. You don't have to calibrate. For example, if you have some fluids that you think that maybe you didn't clean very well or they were harming for your wire, then you can just take a water measurement and see if the thermal conductivity is less than, for me, 1-2% close to the thermal conductivity of water in 20 degrees. I don't propose, usually when I measure a different range of for if I have hydrocarbons, I don't calibrate it all the time. I just check once per month, or it depends from the use. If you go from hydrocarbons to oils, yes, I would say it's better to calibrate it, or at least to check the thermal conductivity to see for your safety, just to be sure
Right.
that if your sensor is behaving in the same way. Maybe you will just make the check and everything will be fine. Usually I don't need to calibrate it. It's not because you don't touch the wire. If there is any change, it means that, for example, if you stay for a couple of days at higher temperatures, maybe you will need to check also the screws if they are untied because you were at higher temperatures. Because you tie them again or you touch the sensor, you play with the sensor with the screws, in that case, probably you will need to calibrate the sensor. But if you have simple fluids and you are careful with the use, even in case you have oils, if you just clean them in toluene or heptane or something like that, and you try not to harm them, you just dip them in the solution and clean them and let them dry, then you will not need to calibrate the sensor.
Okay.
Yeah. But the most of the cases, because I'm trying to check the devices, how they are behaving, and I use them every day, and I have sometimes I have the same sensor in different device. I just measure water to make sure that the sensor is working the same. I don't usually have to calibrate the sensor.
Yeah, that makes sense. And so the manual would be on that USB drive.
Yep.
Yes.
Okay.
But we'll, as you said, yes, you asked, we'll send you everything on your email.
Yeah, perfect. Thank
Yep.
you.
Yeah. Something else you want to answer you? Of course, you can contact us for any question you have. But since we are online now, it's easier to ask anything you want.
Yeah, so I think I'm okay with questions. And it seems like it's not too bad of an assembly with all the equipment. It seems very simple.
No, and in my opinion, because I work with different THW devices, especially in academia, for me it's like a really simple to use device. After a couple of times you use it, you will see that it's like you just put the fluid inside, you set the conditions of your measurements and you forgot it, and then you just go for a check to see if everything is fine, but really takes the measurements and you get your results, and everything is fine.
Yeah. Do you have a cleaning procedure that you do? Do you just use Kim wipes and try to?
It's good not to touch the wire with anything.
I mean, like
uh,
the inside of the container. Any?
Inside the bucket, you can use some wipes. Usually I use the I put the solution totally, it depends what I'm measuring. If I have oils, that usually they are the difficult ones. I use heptane or toluene, just dip the sensor inside, make sure that cleans. And then maybe I remove any remainings from the metal parts with some towel, but don't touch anything with on the wire because you can um, destroy the wire and you will need to change it. But inside the bucket, you can use towel. You can put some acetone. Also, acetone it's very easy. If it's working for you, the fluids you are using, you can use acetone that is drying very easy. Yeah, you can just clean it from inside later with some paper towel, something that will not leave any uh, fibers inside. You can flush it with air. Yeah, but the bucket is the easiest part to clean. You need to be careful about only from the area where you have the wire. Um, so you will not touch it with your hands. You will not touch it with some um, um, paper towel, something like that. Other than that, with any chemicals you want with the typical solutions, yes. Even in soap, you can even put it in soap water, hot water, if it's also if you have a fluid that you are measuring that you can just rinse it with water. Yes, you can do it, but just let it dry or remove the most of the water you can and then let it dry in air so you will not harm the wire.
Okay, yeah, that makes sense.
Yeah. If you don't have anything else, I think we are done. Otherwise, I'm here.
Yeah, no, I think that was pretty much it. It was definitely
Yeah,
helped me out um, with how much time I think I'll need to get familiar with it.
yeah. Yeah, when you set up everything for any questions, we are here. I think we have all the details, even if I forgot something, it's in the manual. But if you have any questions, we are here and happy to answer you, to assist you with anything. So, yeah,
Awesome. Thank you guys.
I thank you.
Thanks very much. And we will send you a link to this recording. Like as a private recording, it's just easier to look at this than to take notes, basically. So we'll send that to you in a bit here.
Awesome. Thank you.
So, thanks very
Thank
much.
you. Bye.